Good morning, guys. Today we are doing lesson 2.2.2, which is about something called the difference quotient. So go ahead and title your notes, and then we'll get working on the warm-up. As always, I would love for you guys to pause the video, try the warm-up on your own, and then we will review it. So quick review of order of operations from last class. Remember, we used to call it PEMDAS, please excuse my dear Aunt Sally, P standing for parentheses. Now G, we call it GEMDAS, stands for grouping symbols. So parentheses, brackets, any sort of grouping symbol like that, okay? So here, to simplify this using order of operations, we're first going to look at the parentheses. So negative 1 squared is a positive 1, minus 3 times 1 plus 2 is a positive 3. And then we're going to multiply the 3 times the 3. So we did grouping symbols, then multiplication, then we're going to subtract, last but not least. So this becomes 1 minus 9, which becomes negative 8. And that's our answer. Okay, and then another review from last lesson, we are going to find f minus g of 2. So you could do this one of two ways. You could find f of 2 minus g of 2, which is what I will show you guys, or you could find f minus g first, so subtract the functions first and then plug in the 2. Either way. Okay, so if I do f of 2, that means I'm going to plug in 2 for function f first. So I'm going to get 2 times 2 minus 3. I'm going to put that just in brackets and all in pink so that I know that that's function f of 2. And then minus g of 2. So that would be 1 minus 2. Plug that in for x here. Okay, and then I'll simplify those first before subtracting them. So 2 times 2 is 4, and then minus 3. And then we've got 1 minus 2, which is a negative 1. Okay, and then here 4 minus 3 is 1. 1 minus a negative 1 becomes a positive 1. I'll write that in that same color. And so 1 plus 1 becomes 2. And then we're done. All right, so moving on to today's stuff. This is the difference quotient formula. Please go ahead and write this down. You are going to use this a lot throughout the chapter. This is something that you don't necessarily have to memorize because you will be able to utilize your notes on all of your assignments and all of that. So the formula for difference quotient is f of x plus h, so plugging in x plus h for a function, minus f of x, the original function, and dividing it all by h, where h is not 0, because if it was 0 and you divide a fraction by 0, you get undefined or you get an error. Now, you guys do not really need to understand the full meaning of difference quotient. This is something that we use in calculus primarily. So for our purposes for this class, we're really just going to do the algebra of the difference quotient and just manipulate the formula. But just to give you guys kind of a general idea, in calculus we use this because it helps us determine the slope basically of a curved function, which we use a lot of curved functions in this class. Obviously, we can find or calculate the slope of a line, but when it comes to something like a parabola or a cubic function or some sort of polynomial that has a lot of curves in it, we don't necessarily know how to find that slope because it's changing. Or if you think about coronavirus and how the spread of that has changed, it has not been a constant rate. But mathematicians, scientists, medical officials, they have to calculate, and they want to calculate the rate of change for specific times or specific intervals. And so that's what h involves. That's what h represents, is that specific time or specific interval. So in essence, that's what difference quotient means. Again, you don't really have to remember that. This is just kind of a preview of what's to come, and for now we're just going to use the formula. So I will go through the steps with you. We'll kind of break it up into 3 different parts, and then we'll do a few examples with all of those put together. So step number 1 is to find f of x plus h. That's the first part of the formula, obviously. Okay, and so that's why we could find it separately if we want to first, and then we'll do the rest of the formula. So f of x plus h, again, just means I'm plugging in x plus h for the input inside the function, or replacing x with that. So I would get 3 times, instead of x, times x plus h, and then all of that squared. okay? And then to simplify this, be really, really careful here. You cannot just square the x and square the h. You have to expand this and write out x plus h times x plus h, and then you're going to distribute. Now, for our distribution, I am going to distribute x plus h times x plus h first and then multiply the whole thing by 3. But remember, we learned in chapter R that multiplication is commutative, so it doesn't matter the order you multiply it in. So I'm going to write the 3 out in front times x is x squared, x times h is xh, h times x is hx, or I'm going to just write it as xh because, again, same thing, it's commutative. H times h is h squared. Then I'm going to simplify. I can combine my two like terms here, so I get 3 times parentheses x squared plus 2xh's plus h squared, and last step is to distribute this 3 inside the parentheses. So I get 3x squared plus 6xh plus 3h squared. Okay, so this, yes, is kind of messy. It's a lot of algebra, and what we just did is we found this first chunk of the formula. So we determined what f of x plus h is. Next step is we're going to subtract the original function f of x from it. Okay, so step number 2 is subtract f of x from f of x plus h. So we already know what both of those terms are. All right, we're going to take f of x plus h right here, 3x squared plus 6xh plus 3h squared. I always put it in parentheses, and we're going to subtract f of x, so the original function from it, which we already know what that is, and that's the nice thing. We don't have to do anything there. We just have to rewrite the original. The reason that I always put it in parentheses like this is because if f of x, the original function, has more to it, let's say it had a plus 2 or minus x or something like that, you have to subtract the entire function, not just that one term, and you have to distribute the minus sign, which we'll see in another example. So I always start out by writing parentheses, but here in this instance, because we don't technically have more terms, we don't really need those parentheses, okay? So I can get rid of those, and then I just combine any like terms. So 3x squared minus 3x squared, that simplifies, and I'm just left with 6xh plus 3h squared. Okay, so that's the numerator of the formula, is what I've just done. And the last step is to divide by h. Now, a quick thing here that will help you guys, if you remember this, you are wanting to get h in every single term. So you should be left with an h in every single term. This should say combining like terms. So if there's not an h in every single term, you have done something incorrectly, and you want to go back and make sure you look for that mistake. All right, so last step here in the process is to divide the entire thing that I found by h. So I have 6xh plus 3h squared, and I'm going to divide that whole thing by h now. Okay, now what you have to do first before you divide it by h, this should say numerator, is factor h out of the numerator. And because it's supposed to be in every single term in the numerator, that should be a pretty easy process. So if I factor h out, that just means I'm going to write it out in front, and I'm dividing both of these terms by h. So 6xh divided by h would just be a 6x, and 3h squared divided by h would just be a 3h. And then I divide all of that by h, okay? So once you've factored h out of the numerator, you're able to divide those h's out, and then you're just left with the 6x plus 3h, which is as simplified as it's going to get. So that, in essence, would be the slope of this function at that h value, okay? So again, it's kind of a messy process. It's a lot of algebra. That's what's hardest about it. But once you guys get familiar with this and you practice using the formula and, doing all of the math, the addition, the subtraction, the multiplication, I promise it'll actually get a lot simpler and kind of repetitive. So here's our second example. Okay, we've got f of x equals 5x plus 3. I always start out by writing f of x plus h minus f of x all divided by h. I just repeat the formula just so that I make sure I'm including every single part and piece of it. I would even suggest, if you guys have different colored pens or highlighters or pencils, using those like I'm using that here, because it can get real messy real fast, so it kind of just helps to make things clear. Okay, so first thing we're going to do is find f of x plus h. So we're going to plug in x plus h for that x, so 5 times x plus h plus 3. I'm going to put this whole thing in brackets because we already have parentheses, so that's f of x plus h. Okay, that's the hardest part. Then we subtract the entire original function, f of x, so subtract 5x plus 3. Again, we want to make sure we put that in parentheses. And then we're dividing that whole thing by h. So I'm just putting all the steps together in one so that we don't have to take as much time. Okay, so I'm going to simplify f of x plus h. So I'm going to distribute this 5 inside the parentheses. So we get 5x plus 5h plus 3. Okay, and then I'm going to distribute this minus sign inside the parentheses. This is like multiplying a -1 on the outside, which flips the signs inside the parentheses because we're subtracting the entire thing. So minus 5x minus 3. Okay, all of that divided by h. Now I'm going to see what cancels out here. So 5x minus 5x, those subtract. 3 minus 3, those subtract. And then we're just left with 5h over h. Remember, what we're left with in the numerator should have an h in it. If it does not have h in it every single term, then something's wrong. Now here we would technically want to then factor out an h. Well, it's really already written in that form for us because we can just divide the h's, and then we're left with 5. Okay, so that's example number 2. Example number 3, we've got f of x equals x cubed minus 2x. I'm going to write this on a separate sheet of paper just because this one gets a little bit bigger and a little bit more messy. So let me just write this out here. I'm going to add a page below. Okay, so starting with f of x plus h, we then want to subtract f of x from that, and then we want to divide the entire thing by h. So let's plug in f of x plus h. So I'm going to replace my x's with x plus h, so x plus h cubed minus 2 times x plus h. Again, we want to put this whole thing in brackets, minus f of x, so our original function, so x cubed minus 2x, all of that is in parentheses. And then divide that entire thing by h. Oopsies. Okay, so f of x plus h, we've got to simplify that, and this is where it gets a little bit more messy because of this x plus h, all of this cubed. Do you have a problem like this in your homework, which is why I'm going over this with you guys? So we are going to expand that out till we have x plus h times x plus h times x plus h. So that's what it means to be cubed, okay? And then I'm going to go ahead while I can. I'm going to distribute these other couple things. So I'm going to subtract 2 times x, so 2x, and minus 2 times h is a minus 2h. Make sure you carry the sign in front of that, which is a minus 2. All right, and then on the other side of this, I'm also going to distribute this minus sign. So minus x cubed, and then minus a negative becomes a positive 2x. So that once I'm done with the rest of this out in front, I can just go ahead and simplify. Okay? So now I've got to distribute x plus h times x plus h times x plus h. So I'm going to just start by multiplying 2 of them. So x times x times h times x, h times h. We've already done that in the previous example, so this gives us x squared plus 2xh plus h squared. Okay? All of that is still multiplied by this third x plus h. And then we've got minus 2x minus 2h, all of that minus x cubed plus 2x, all of that divided by h. Okay, so now we've got to distribute this one more time, and this is where we have a lot of terms, so stick with me. So x squared times x is x cubed. x squared times h, we have to multiply this times both of these, is x squared h. So we're done with the x squared. Then 2xh times x is 2x squared h, because we've got the x and the x. 2xh times h is a 2xh squared, because we've got the h times the h. All right, and then the last term, h squared times x is h squared x, or xh squared, either one. And then h squared times h is h cubed. Phew, we're done with that, okay? And then I'm just going to write minus 2x minus 2h, all of that minus our x cubed plus 2x. All of that divided by h. You guys should be very proud of yourselves. This is very, very, very messy. Okay, but it'll get a little bit easier. So now I'm looking for things that I can subtract or add together to get rid of. So I've got an x cubed and a negative x cubed. I've got a negative 2x and a positive 2x. And then let's look for things we can combine. So we've got an x squared h and an x squared h. We've got an x h squared term and an x h squared term. And then we've got two loner terms, okay? So we're going to combine those, and we'll have 3 x squared h's plus 3 x h squareds plus the h cubed minus the 2h there, okay? And then all of that still divided by h. All right, so we did that. That's the hardest part. Now that we've got the numerator, we check to make sure every single term has an h value in it, which it does, and then we factor that out. So we're going to write the h out in front. When we divide that out, we get 3x squared plus 3xh squared divided by h is 3xh plus h cubed divided by h is h squared minus 2h divided by h is just a 2. And then all of that is divided by h. So we divide the h's out, and we are left with 3x squared plus 3xh plus h squared minus 2. All right, so that is definitely a long one. And like I said, this can seem kind of overwhelming at first, but when you think about it, all we did is a lot of multiplying and a lot of adding and subtracting and dividing. So yes, it's long, yes, it's messy, but the process itself, when you break it up, is not actually super difficult for every single step. It just can get messy and easy to get lost. Okay, last example, this is actually problem number 6, I believe, on your homework. So this will be nice because you guys can already check this problem off. We've got f of x equals 1 divided by 1 divided by x. So I'm going to also add a page in case we run out of room here. All right, so f of x plus h, we'll find that, subtract f of x from it, and divide that entire thing by h. You guys are probably getting used to me saying that by now. Okay, so plug in x plus h for our x, so 1 divided by x plus h. Okay, this is f of x plus h, minus, we're going to subtract 1x, or 1 divided by x. I'm tripping over my words today, guys. I apologize. All that divided by h. Okay, now we have a fraction within a fraction. So what we've got to do first is we have to combine the numerator. And remember, in order to get a fraction minus a fraction, we have to have a common denominator. So what we're going to do here to get a common denominator is we're just going to multiply each denominator by the other denominator. So x plus h and then x, okay? So I will rewrite this over here. We're going to have 1 over x plus h, and we're going to multiply that by x over x, okay? So that's the other denominator over here. And then we are going to subtract 1 over x, and we're going to multiply that by our other denominator. So x plus h over x plus h, okay? And then that way, when you look, so when you multiply these, this just becomes one fraction, okay? Then we have x times x plus h in the denominator, which is a common denominator now. Okay, that's the same, and that's exactly what we want. And then all of that is divided, all that messiness is divided by h. Okay, so this in the numerator is its own entity. So let's rewrite that. We've got now, if I multiply 1 times x, this is just x divided by x plus h times x. All of that minus 1 times x plus h is just x plus h, so minus x plus h, all divided by x plus h times x. Okay? I'm going to write that in brackets still, and that's still divided by h. Now that I have a common denominator, I can subtract, and I just subtract the numerators. So I take x, and I subtract this whole thing, x plus h, and that's why you have to keep it in parentheses, and that's divided by my common denominator, x plus h times x. So you don't rewrite that twice, because remember, if you think about when you're combining normal fractions, like if I have a 1 out of 3 plus 2 out of 3, 1/3 plus 2/3, I just add the numerators, 1 plus 2, because I have 1 piece out of 3 plus 2 more pieces out of 3, so I have 3 whole pieces out of 3. You keep the denominator the same. Okay, so that's why here we keep the denominator the same. All right, then we are going to distribute this. So we get x minus h, all divided by this common denominator, all divided by h. Okay, and then the x's cancel out, so we're left with just a negative h divided by this common denominator, all of that divided by h. Now, dividing by h is the same thing as multiplying times 1 over h. And that's what I want you to rewrite it as, just because when we have a fraction within a fraction and we're dividing it, this is actually the same thing as just writing times 1 over h. And the nice thing about that is that these h's are then going to divide out, and we're just left with a negative 1 in the numerator divided by x plus h times x. And voila, we're done. Again, this one is one of the most challenging on the homework, which is why I wanted to do it together with you guys. I promise a lot of the other ones are a little bit simpler than this, but now you guys have at least seen how to do difference quotient with a fraction like this. Okay, so those are the only examples that we're going to go through. Thanks for hanging in there today, guys. And you have a 2.22 worksheet this time, so these problems are not out of the book. They are on a separate worksheet, which we've included on Google Classroom, or if you are in class, we will have a printed copy for you. So please make sure that you practice all 9 of these. There are 9 of them, and we did one together, so really 8 of them. Because that is the key thing to being successful with difference quotient, is you have to practice. Practice, practice, practice. All right. Good luck, guys. Let us know if you need help.